arrival to these network models is one that's more expansive and involves different sorts of memories, and that's the adaptive control of thought models, ACT, developed by Anderson, who had a very influential textbook, by the way. It assumes working memory, declarative memory, and procedural memory all exist, and it has a way of accounting for each of these. So Anderson believed that declarative memory stores information in networks that contains nodes. There are different types of nodes, etc. As with any other network models, ACT models allow for both activation of any node and for the spreading of activation, as we saw in that yellow graph that we just saw. But he also proposed the existence of procedural memory and production rules. So he gives a lengthy example here in the text, or Galati does, a production rule for multi-column subtraction, and allows for a procedure to have existence within the context of a spreading network. So you could read through these particulars, but production rules for multi-column subtraction. If the goal is to solve a subtraction problem, then make the sub-goal to process the rightmost column. If there's an answer in the current column, then there's a column to the left, etc. The particulars of math. So the fine points of this are a little bit beyond us, but it's interesting that he expanded that to allow for a process. So his proposal was not meant to merely address the question of knowledge representation. His aim was to create a theory of architecture, a theory of how human thought operates in practice, and he proposed a system that includes memory storage and processing structures. So this broad goal led him to develop proposals about knowledge representation that fit well with those researchers whose aims were more focused. So in the ACT models, working memory is actually that part of declarative memory that's highly activated at any particular moment. Now, this is different. Normally, working memory was not considered to be part of long-term memory, but in his proposal, it is. The production rules become activated once the nodes in the declarative memory that correspond to the conditions of that production rule are activated. So in a few weeks here, actually about 10 days, I'm going to have to fill my taxes out. Now, I haven't done that in roughly a year. But upon encountering those forms, the same ones I fill out every year, some memories will come flooding back to me. And you could argue that those procedures are part of LTM. So there's a product of tax forms, for example, that it's a standard deduction. Now, most people, and I'm one of them, don't have enough charitable deductions and other things to be able to itemize. So there's a fixed amount that you can reduce from your income, and that mitigates your tax plight somewhat. But that particular procedural memory, where to enter that, hopefully will come flooding back to me after roughly 52 weeks since I last did it. And in that case, this would validate Anderson's proposal that it's not merely a matter of working memory, but it's your long-term memory that has procedural memories in it and that become activated upon sitting down to do taxes or to do any other sort of procedural thing that you seldom do. Another one is a flat tire. I don't know how many flat tires I've had in my life, maybe 8. It's always stressful, very unpleasant, but I've gotten pretty good at it. I go get the jack, and I know how to position the jack under the car and how to elevate the car to replace the tire. It comes flooding back to me in those times of emergency, and Anderson allowed for that in his spreading activation model.